Hello, everyone, and thank you for attending today's webinar, Higher Performing Broadband, Meeting Higher Demanding Expectations, presented by Zyxel. I'm Elena Heiler, and I'll be moderating this webinar. Today, our speaker is Patrick Marino, Product Marketing Manager at Zyxel Communications, Inc. You can read his full bio on the left side of your window by selecting the Speakers tab. Just a few technical notes before we begin. The webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your volume is up. This webinar is being recorded and will be available on demand within 24 hours after the event. Time permitting, we will follow the presentations with a Q&A session. Please submit your questions using the Questions and Answers tab on the left-hand side of your screen. Okay, now let's begin. Patrick, please go ahead.
Thank you very much for that introduction, and thanks everyone for taking the time and interest today and attending our webinar with Fierce Wireless. High-performing broadband meeting higher demanding expectations, access technologies with PON, 4G LTE, CBRS, and Wi-Fi 6. Before we begin, I'd like to thank our host, Fierce Wireless, as well as our sponsors, Border States, CSSA, KGB Co., Graybar, PowerIntel, Walker & Associates, and Wincom Technologies. So, ranking in 2021 for the fastest and lowest speeds in the United States, we see in the red is actually the slowest ones we see in some of these states like Alaska, Montana, Mexico. But states that have really fast broadband are Texas, California. We do see New Jersey as well as New York. So just an average mix about 99 megabits or so in the performance. Now, some states may be offering much higher bands, and some may be a little bit slower. So with the rise of all this broadband and IoT in 2020, we've seen 244 billion expected to grow exponentially with the 286 billion in from 2021. So pretty much a 17% growth year over year. A lot of that has to do with video. A lot of video traffic, about 70% of all internet traffic is video. That also includes what we see in gameplay, not just the traditional consoles and computers, but we also see the advent of the virtual reality, augmented reality, taking about 12 times that we've seen from 2017. Also, since the recent changes in our environment, the home gym has really changed the way it's not just that clothes hanger where you throw all your clothes on the other side of the room. Now you're actually interacting, has a screen, and you can actually work out with other people in different areas around the world. People spend roughly about $40 or so a month for just the membership, as well as for the equipment that they put in the home, whether it's cycling, a mirror, and other equipment that's involved with working out at home. So we're going to take a look here at broadband, and we see that three kind of segments that really kind of help provide that and then pass that along into our home. That's for the fiber with the PON networks, as well as wireless. And we see that advent of 4G LTE and the emerging CBRS technology, and then delivering that within the home with the latest in Wi-Fi 6. So with fiber, and we kind of specifically look at a 10 gig solution, XGS-PON, helps deliver that access demand. We see a growth in a two-box type of solution that allows us to be flexible with the deployments, as well at the same time, the lower latency, so for those time-sensitive applications like that video we just talked about, and enhancing the reliability with security, and the ability to build upon existing networks and help your company scale to meet the demands from the subscribers. With that, fiber is pretty flexible, and we have a lot of 1 gigabit GPON networks that are available And with this newer 10 gig, 10 times the ability of speed, we can build upon that same network and allow us to grow and open up new markets with the ability of higher bandwidths. That's achieved with the ability of bringing two access technologies that are pretty similar related. The GPON that brings in 1 gigabit and the XGS-PON that brings in 10 gigabits of performance over that same network, and utilizing different wavelengths helps separate the two and provide the ability to have that type of network, two technologies running over the same network at the same time. When we take a little bit closer look at the wavelengths themselves, you can see from the GPON in blue as opposed to the XGS-PON, the 10 gig in the amber or orange. You can see the changes there with the different frequency ranges. They don't have any interference with each other. That means they can run them over the same network and not impede each other. Then to extend that network out with that fiber from your central office, you can go and split that off from a 10 gig connection. From there, you can segment that off to smaller connections, providing a 1 gig connection and thus reaching your subscriber base and help build out those areas. Target segments here we see is the single family and multi-dwelling. Using a combination of either GPON or the XGS-PON, which is the 1 gig and the 10 gig variants, here we have the same applications, the same needs and wants from the subscribers in the broadband, the home automation, security, entertainment, and then our new reality, which is the e-learning as well as remote telecommuting. To be able to be nimble, you would want to be able to swap out that technology as it comes available. On the side of the gateway, it changes quite rapidly, as you see, from Wi-Fi 4, Wi-Fi 5, and Wi-Fi 6, 11N, 11AC, and now the AX. It's easier to change out the gateway than take down the whole network for the subscriber. In the central office, you have the same connection point, that ONT, that provides the broadband connection over the fiber, then hands that off to the gateway. Change the gateway's technology. That Wi-Fi could change out and have a new variant in a few months from now that makes it nimble and easy for you to swap out. Even if you have a network with multiple types of wireless technologies for the in-home, you can have different types of product deployed and change those out very rapidly, and in some cases, send it out as a mail offer where the subscriber sets that up with a self-install. In some cases, we can have that equipment closer into the home. It could be in a basement, garage, tucked away in a smart panel, away from the subscriber where they don't have to touch it. All that you can use in this instance is an extender that helps provide that connection. From there, they have that fast, reliable Wi-Fi as the internet experience. For business applications, it's very similar. You can tap into their existing infrastructure by adding a fiber connection, whether it's a GPON or an XGS-PON ONT. From there, it'll connect into the LAN and provides that high-speed connectivity that they're looking for to allow them to have a large pipe connecting out to the internet, lower latency for time-sensitive applications, and the ability of cloud services like unified communications, virtualization, and network storage. Bridging that gap between those technologies, utilizing a combination of fiber and Ethernet to be able to add those devices together and create your network. In the office environment, you have a robust network and a gateway that can handle that. Also, the ability of adding that micro small SFP interface device that's an ONT and put it into the gateway to provide that connectivity for a broadband connection. In this instance, we can use this for a business application or even a residential multi-dwelling, providing a fiber to the building, from the building into the switch that has an SFP interface, which is that XGS-PON 10 gig, and provides plenty of bandwidth for all the connected devices. As you see in this example, we have 8 Ethernet gateways that are Wi-Fi 6, all connecting to different subscribers within the building and providing that connectivity. to manage your environment with a fiber and utilizing the PON technologies. We use the GPON or XGS-PON to manage those from your central office. We use a technology called Optical Management Control Interface, the OMCI G.988 standard. This allows for communication between the central office and that fiber ONT deployed device. Once installed, it will communicate back home and allow itself to be registered. From there, your central office will send down commands to tell it what to do, and periodically, the ONT will interface with your central office and provide updates and status of its connection. In the past, interoperability has been a big challenge, and it's always been a kind of a landlocked system where there's no room for real growth for the provider. So unable to bring in a secondary or third-party vendor for no expansion of the network. Also, the software ecosystem is closed, which doesn't allow for outside innovations. Even if there's some great ideas out there, you can't bring them in. This really comes down to a one-size-fits-all approach. You're in this ecosystem and you're hopelessly kind of stuck and you can't get out. And one of the main pain points is a proprietary management system, which is like a swivel chair. So if you have different equipment deployed in your network, you got to hop between different management interfaces, which makes it really challenging for the NOC staff to be able to manage what's going on, hopping from interface to interface. So we've taken some cues from our brethren in Europe, and they've gone to a more open standard where they allow you to kind of pick and choose components, but still adhere to the standards like the OMCI, the G.988. Here, you can select the ONT vendor of your choice, then the ONT for the fiber endpoint, whether it's an outside plant, a fully integrated gateway, a single port device, or a micro small form factor like an SFP. And then tie that together with your management system of choice. So you have that flexibility to kind of pick and choose. If there's a specific issue with a vendor, you can always rely on the second source, or depending on your deployment territory and region, you can select products that are really conducive for that environment. So I think we come up to our first polling question here. And what 10 gig technologies is your company most interested in deploying? So go ahead and make those selections and submit that in. Give you a few seconds here to go ahead and do that. All right, see some results coming in. Okay, so looks really good. I'm quite surprised. I think we have the right audience mix in this webinar session that we have. Looks like XGS-PON is the leader here with 10 gig Ethernet, slightly behind it. Great news. Okay. Thank you, everybody, for taking the time to join our polling session here. And we'll go ahead and move on. Oop, there it is. Yeah, 50%. Really good. Excellent. Okay, so now we're going to transition gears to our other access technology in the fixed wireless. We'll talk a little bit about 4G LTE and the CBRS. So why LTE 4G? Well, it's a great alternative for internet broadband access. It provides performance up to and beyond, in some cases, all wireline connections. The nice thing about it is the service providers, operators, even building owners can create their own private LTE network. It's not very difficult. It's great for outdoor deployments. It's weather protected, hardened equipment for different types of in-stream environments, as well as the ability of not having to put electrical conduit on the home or a building. It has the built-in PoE that allows for that deployment to be a little easier. And then there are management systems out there available to help provide the connectivity and the status of those devices being deployed. Multiple radio design. It has different technologies. Think of it as like a little mobile phone that you have. Your mobile phone has Wi-Fi, it has a cellular, it has Bluetooth, and a lot of these LTE devices do support that. Also, with the high-speed access, it's really conducive for broadband access. And in some cases, in remote areas where there's only satellite or DSL, it can actually outperform those technologies. And really great for the rural applications as well as building in a metro urban area. Enclosure helps with directional antennas that are kind of a point and shoot application. So it really, helps with setting up that deployment. Don't have to spend too much time trying to do a survey. Great for different applications. We see distances from 5 up to 10 miles in distance with this, believe it or not. And with CBRS, there's 2 categories that have the ability to interconnect within the network with a SAS, a Spectrum Access System. But others have the end user device, which allows you just to freely connect like an unlicensed wireless network and doesn't require extra fees for associating. And in most cases, for an indoor device, you can have that sent out to a customer subscriber, and they can set this up by simply putting a SIM card in, plugging the power, and allowing it to register to the network. Coming up on the horizon, we hear a lot of talk about this, and sometimes it's kind of frustrating because we thought we would have it now, but the 5G is coming, and that next generation of wireless promises to deliver really fast speeds to meet the demands of broadband these days. We also see that as a technology that can rival, some of the technology we use like fiber and the Wi-Fi. This new breed of 5G NR devices are in that final stage of being developed with all those aspects in mind. So something that we're probably going to see towards the beginning of the year, a whole slew of products coming out with that next generation of wireless. The setup is very simple. In the outdoor environment, we just simple connection from the outside into the home, connecting to a standard residential gateway, and then from there you have that ability to connect, whether you have your existing wireless network or utilizing something that's built into the device to provide that connectivity. In the home, it allows that to be transparent for the subscriber. All they're doing is just like they would assume Wi-Fi is the internet. You just connect to it. Works with a wired connection, bringing it from the outside into inside the home, as well as the ability to cover it a single family or multi-dwelling. And again, most cases can be a self-install option for providers. For multi-dwelling 4G access, sometimes in some applications, you just don't have access rights to the building where you can actually touch the wiring and bring in broadband. You don't need to worry about that. All you do is use a 4G LTE or CBRS indoor device, place it by the window, and you can beam the signal right in there, just like you do on your mobile phone. Works in a very similar fashion. No need for heavy installation of hardware. The whole gateway is all inclusive itself, and it connects to the cellular network, as well as allows the subscriber to have that connect to their existing wireless, home router, and have that luxury of utilizing 2 devices within the home. For the teleworkers or really the remote learning, fixed wireless has been a godsend here, which provides the ability to connect all those people who don't really have that access to good broadband. We can provide that remotely with LTE, 4G, or a CBR solution to allow them to gain access to broadband and then thus get their video lessons and learning. To manage all this with the fixed wireless, we turn again to the cloud to be able to help enable us to manage all those deployed devices without having to send a crew out to help administer that. That's done with the ability of utilizing all the 4G LTE, the CBRS, and even 5G. Helps reduce the cost because it's a cloud instance. You don't really have to send a crew out to help maintain it. Your internal tech support center, as well as the install crew, have access into this since it's cloud-based. It's up 24/7 and improves the response time. It's a secured connection, zero touch. Again, you see all your deployed devices that are fixed wireless, as well as manage the network and cellular settings, update the routine maintenance like firmware updates, change configurations, and you can see analytic data can be gathered and look for issues that could arise and help prevent them from appearing. So now we're going to take another change. We already have two access technologies that really bring us closer to that subscriber, but now we're going to immerse the subscriber in the Wi-Fi environment that we all know and love. And now we look at the newer technology of Wi-Fi 6 to help improve that along with the mesh. So we see that the needs for a high-speed broadband access, at least about a 1 gig or so, to help really enhance the experience. The routers work with the extenders to help improve the coverage within the home. Also, with the home mesh system, we provide the ability of load balancing with band steering and the roaming, and it's all done with a single SSID, so the subscriber doesn't have to do really much. As well as help with the dead spots, the extenders really provide that extension of the wireless network. And all of this can be managed through the cloud or within the traditional TR69 to help reduce costs and routine maintenance. So we take a look at the evolution of the router back in the early 2000s. People were just getting on board with Wi-Fi, and it was the greatest thing. But we've progressed since then, since its speeds have really climbed up. We've had the ability of a wireless router that goes beyond 1 gigabit performance speed in the network. And now we're seeing that gateways provide the intelligence to help us manage the whole network, not just provide broadband access. That's where the intelligence comes in. So gateways, the extenders, they actually have some brain power in them to help manage these environments for us. That's done through, we see in the brain trust of the Wi-Fi management, the self-organizing network. It takes all that data that's input and output from your gateway and your extender and your wireless clients and feeds it into the system and analyzes that, and it helps that with the network configuration. It helps work with the hardware of the gateway, with the radios and the SSID, the wireless work group name, and helps straighten that out and allow for a cohesive network to roll through. And in some cases, it'll take a look and try to provide help and moving devices around to different bands to be able to achieve that. So that lends into what Wi-Fi 6 can deliver. Obviously, it's the speed that we're looking at, about 4 times what we had in the past, as well as more connected devices, more capacity than we had before. On average, we're seeing homes with 25 or more connected devices, and that number is going to jump up in a year or so with we see 35, 40, even 50 devices or more. People are already at that threshold as we speak, which is why we need Wi-Fi 6. The lower latency is important, time-sensitive application, so we improve upon airtime techniques to help that. And with all these mobile devices, they rely on battery power. And how do we preserve that? Well, there's techniques within Wi-Fi 6, target wake-up time, to help ensure better transmission times to use the device to communicate within the network, thus saving battery life. So 4 times, about 30 to 40% improvement over our existing Wi-Fi 5 network with Wi-Fi 6. Increased capacity, about 4 times the amount of devices. So it's not just your laptop and your mobile phone and your tablets. Now we see all kinds of devices, cameras, game consoles, media streamers, voice assistants, thermostats, all these IoT, even light bulbs take up bandwidth. The more capacity you can have for those devices, the better your network is going to be. Also, with connecting to legacy, Wi-Fi 6 has to ensure that we can continue to support Wi-Fi 4 and Wi-Fi 5 devices going forward, as well as the new Wi-Fi 6. Without that support, we're not going to have two separate networks, which is not very conducive. We want to have one holistic network that supports all these devices going forward. So when all those devices are working in unison, they work kind of like a beehive, and they push that communication around. So the more devices you have, the better your network is going to operate and be able to communicate. Even though you have slower devices like a Wi-Fi 4, Wi-Fi 5, to still contribute and allow that propagation out. So with the battery life, we use techniques like target wake-up time to help find better times to communicate and reduce the battery consumption. With the performance of Wi-Fi, we use 160 megahertz here. We have the ability to provide what we call an HOV lane for your Wi-Fi technology on the 5 gigahertz band. Most Wi-Fi 6 products are up to 80 megahertz, and the ones that do support 160 really have that ability to really provide a really interesting environment for the Wi-Fi 6 products. Exclusive lane for all those devices together, we double the 80 megahertz channels together to get a 160, and having the ability of a gateway with an extender to be able to provide that really is going to have huge benefits for your wireless network. So with Wi-Fi 6, there's a lot of technologies under the hood, and what some of those are is the multi-user MIMO. We've seen this before in many years with the wireless, but here we have the ability of bidirectional support. So once the clients have support for multi-user MIMO as well as the gateway under Wi-Fi 6, there's a two-lane street. So there's communication going both ways, which thusly improves the performance of your network. Also, the orthogonal frequency division multi-access is an airtime technique that helps aggregate all the wires together to allow for better communication and use of the airtime to transmit. As well as the quad-share M2 modulation, it's just more lanes. So instead of going on a single road, we have on an interstate with multiple lanes going in one direction, which helps improve the communication. And then the beamforming helps with dedicated connections between the gateway and the client devices, so it knows where it's at and it knows not to have to waste its energy transmitting, sending signals out when it knows there's specific devices there within the wireless network. To help with the classification, how do you select the device? Our industries come together and said, okay, let's do this. Let's give you the max speeds of the 2.4 AX and the 5 gig AX, combine those two numbers together to give you a classification. And here you can have a ranking. So when you go to the big box store, home improvement, or you're online looking for a Wi-Fi 6 product, now you have an idea of what those devices and their performance can be. So in the lower scale, like from 1,500 to 3,000, that's more or less the client adapters. And as you go higher, then you're going to see Wi-Fi routers and extenders. A perfect example is AX6000, which is 1,100 megabits on the 2.4 AX, and 4,800 megabits on the 5 gig AX. Combine those numbers together, you get AX6000. So you have your classification and an idea how to kind of select some products for your network. We use a single SSID, wireless workgroup name, that encompasses both 2.4 and 5 gig. They still run independently and they don't interfere with each other. However, they're joined together by that single name. So it makes it easy for your subscriber to connect with that type of network. Once it connects, that SSID is locked in, then the gateway takes over and it acts like a traffic cop. And it determines what's the best network for you to connect to without you having to select anything. All you do is select the SSID and you're done. At that point, the gateway takes over, analyzes the network, uses a lot of calculations, and it takes account to all the connected devices. You may be on 2.4 or you may be on 5 gig, depending on your device, and you may be on the router at one point, and then later on during the day, you could be on the extender. And you don't have to do anything, nothing for you to select, nothing for the provider to select. It's all done automatically behind the scenes. To extend your coverage out, most gateways these days have enough output power, about 1 watt of power, which really is conducive. So 80% or more, you just need a gateway. But in some cases, there are some trouble areas that we know, call those the dead spots, and we need an extender. And you need that extender to help provide that coverage area. And in specific deployments, again, we can have up to 3 extenders talking to each other, as well as a gateway to provide the coverage in your subscriber's network. With great Wi-Fi that's on, how do you take advantage of that with the internet connection? You having the ability up to 2 gigs. So we see a trend here with providers looking for 2 gig services that they can offer on their wireless. It makes it attractive for people to go in and pay a little bit more, but get a little bit more performance. Here we have that transition from a 1 gig up to a 2.5, which really allows you to have tiered services and match up with that great Wi-Fi that you're already deploying. With Wi-Fi 6 and security in mind, we haven't really had a security update to the Wi-Fi in over a decade. Surprisingly, we haven't done that in more recent times. So with this new Wi-Fi 6, our industry decided, hey, let's update the security. It's a good idea, which they've done, and added the ability of disallowing outdated protocols, which are not necessary and don't really provide great protection. Also, there are management frames that we send from client device to the gateway and back, vice versa. From here, there are also a little bit extra added protection, which helps improve the wireless environment. Functionality is still the same. We still provide a passphrase, or if it's already provided by the vendor on the back or bottom of the device, that can be still used, but protection levels have been upped for Wi-Fi 6. So we'll go to the next polling section here. And with the benefits of Wi-Fi 6, what is the likelihood of migrating to Wi-Fi 6? Go ahead and let's make your selections. We'll see how that goes for our audience. Okay, so we see some results. Okay, so there we go. So we'll get some more results in. Don't be shy out there. You know, some of you know who I am, so don't worry, I won't be mad at you. It looks like a lot of people are still researching Wi-Fi 6. So I understand that because there are some new additions and caveats that are out there that are kind of weighing in on your decision. I completely understand. Also, on the flip side of that, we do see that some people are pretty satisfied with the Wi-Fi 5, and you know, if it ain't broke, we really need to fix it. Okay. That's it. All right, great. Okay, so moving on. So that segues right into our next topic and the Wi-Fi 6. So E versus Wi-Fi 6. So Wi-Fi 6E is a new standard. It's going to be opening up some more spectrum, actually a third band that will be being brought in, and allow us to have what we call a true tri-band device. So there are vendors out there who say, oh yeah, we do have tri-band. We've had it for a while. But it's actually 2 5 gigs and then a 1 2.4, but it's still dual band. It's not real tri-band. True tri-band is going to be 2.4, 5 gig, and then the addition of the 6 gigahertz frequency. So some changes there, definitely. When we take a look at what Wi-Fi 6E application is, currently right now, there are no real clients available to be able to really utilize that 6 frequency. So if you were imagining a Wi-Fi 6 router and a Wi-Fi 6E extender, then we can use that 6 gigahertz frequency for a backhaul. And that would join us, and I'll also have a free connection for performance, as well as freeing up the 5 gig and the 2.4 for all the other devices that we have. So again, increasing the capacity. So Wi-Fi 6E is in development as we speak. We'll probably see a big announcement at the beginning of the year from many of the vendors. So, but what we're saying is no need to wait, because Wi-Fi 6 and Wi-Fi 6E, they're going to be working together. whether one is 3 bands, one is 2 bands, might as well get on board now. There's no kind of real reason to wait. We've already had this technology for almost a couple of years now, and it is proven out to work quite well. My own personal testing, I would say at least a 20-30% increase in performance, faster speeds. I have a Wi-Fi client device that I'm seeing 1,400 megabits easily on the network. So what does that mean for us in the future? Well, with Wi-Fi 6E, there are probably some new variants. Some of the interfaces, they may be supporting up to 10 gigabits. Some will have transceivers. Others will have a direct fiber connection or Ethernet 10 gig, as well as 2.5 and the traditional legacy 1 gig. But there are going to be multiple radios in there, so there'll be probably at least 12 radios or so, or even more, built into Wi-Fi 6E. And it's going to have that backwards compatibility. So you shouldn't have to worry about, what about my existing customers? Wi-Fi 4, Wi-Fi 5, as well as 6 will be supported in a Wi-Fi 6E environment. It's just, again, that addition of that third band, which is going to make some changes for us in how we deploy the networks with Wi-Fi 6E. So taking a look here at the management of this Wi-Fi 6, a lot of the stuff is routine maintenance, monitoring the connection, changing passwords, adding a guest network is pretty prevalent. What about a new device? Doing some troubleshooting and parental controls. A lot of this is routine stuff that we should, not really have to think about, and kind of automatic processes in the back end. That's where auto configuration server and TR69 really are prevalent. So no need to actually have someone at that gateway to do any of the work. It can be done remotely, especially the routine stuff like configuration, maybe some troubleshooting, all can be done remotely. So utilizing the communication of TR69 from the gateway without having to be there, you can do firmware updates, not just to one device, but multiple devices. Change the configuration, even reboot the device if needed in the serving area can be done remotely, thus saving costs for the provider. Now, with the new breed of management and really kind of looking at what the Wi-Fi can do and how can we take advantage of that, provide that, we look at techniques like cloud-based, open source technologies. It's changed the way we've done things in the past. It's always been separate points that we connect the Wi-Fi to, and we join one network and have to join another one. Then we brought in the mesh networking, where it brings us holistic, that same network, but into a way we can roam from one point to another and not lose that connection. So with an open source system and a cloud base, it's the glue between all the connecting points from the provider on their back end into the cloud, as well as a management system that even the subscriber can take advantage and be a part of and help manage their system without having to really know what to do and worry about all the techniques and underlying technologies. For providers, it allows you to bring in new services very quickly and get your deployments up and running with a connection to a cloud and to your central office. Keeps track, like I told you before, about all the vital statistics that are available. Anything that inputs and outputs from your devices that are deployed, you can get information upon that and help manage your network better. Works with multiple vendors, and you can mix and match components as long as they're compatible with this open system. It allows for that connectivity and is scalable. So when you start to grow and you add new greenfield areas, you can get that product to connect and manage those as they're being deployed. So taking a look and adding that into the products, that's a part of that secret sauce with R&D and software development teams. We are able to do that in our industry and embed an agent that helps offload into those devices to help them manage and see them not only from the provider's perspective, but from the subscriber itself. So having the best of both worlds is very important, whether you're traditional TR69 or the new breed of management when the cloud you can manage your Wi-Fi 6 devices and have kind of even down to the extender level. So the big benefits with an open system, you rely on the ability of managing that onboarding devices quickly as well as services and allowing for the analytic data from the subscriber so you can help better support them, as well as the broadband, TR69 that we see. You have the ability to have that traditional network set up and, adhere to performance legacy testing with systems like TR143. So I think we come up to our Q&A. If we have any questions, we can field those from the audience.
Awesome. Thanks so much, Patrick, for that engaging presentation. Now let's move on to Q&A. There's still time to submit your questions using the Q&A tab on the left-hand side of your screen. We have a lot of great questions already, and we'll try to get to as many as possible. So I'll just dive right in. First up, Patrick, is how does fiber or PON technology stack up against other technologies like fixed wireless?
That's a great question. We seem to have always a competing rivalry, whether it's with your siblings. Same thing in technology. There's going to be probably still reliance on the two technologies to really kind of work together hand in hand. So not really competing. We call it co-opetition, where they also work together as well as compete. So fiber, we're going to need that and that PON to connect from your central office to those base station towers for the wireless. Once those are connected, then it'll hand off to the wireless devices. So the two kind of work together. Now, other technologies that are fixed wireless that work really well and could replace other technologies, maybe like satellite or a DSL connection, they're kind of a little bit more antiquated and slower. So there is some competition, but really they're working together to provide broadband in a bigger world for us. Yeah, great question.
Thanks for that. Next up, we have, what is the life cycle of CBRS compared to wireless technologies like 5G?
Interesting. So there's been a recent push in the last few years for CBRS. Really the attraction of creating your own private wireless network, which is really, exciting for providers to get into because, I can own my own infrastructure. I can set up my own towers and provide that connectivity alongside my fiber stuff. However, it's starting to evolve. We know that the fifth generation of wireless products are coming in, right? The fifth 5G. And we hear a lot about it from all the major carriers, talking about we have the fastest speeds and largest networks. But it's really going to work together, just like I said before, with a co-opetition. CBRS is kind of a stepping stone for 5G. So there's the ability of having that network and then allowing you to expand once you're ready to enter in 5G, and it provides those steps in the path to the next generation. So they kind of technically compete, but they're actually kind of like cousins in the sense that they're going to be, related and work together to provide connectivity on a fixed wireless connection. Excellent.
Very good. Next up, we have a question that asks, many Wi-Fi 6 routers have external antennas. Is there an advantage of having external antennas over a router with internal antennas?
That's a great question because that always comes up. And it's really kind of strange for consumer retail market. You'll see a lot of products and they'll have multiple antennas on them. They look like tarantulas, it's just crazy. And I think it's kind of goes back to the old days. Remember when we had like muscle cars and you seen the exhaust pipes coming out of the side. You see that, you think, oh man, that's going to be fast. And that's, I think we kind of dive into that with the Wi-Fi. We see more radios and antennas and we're like, oh my God, this thing's got to be really good. But the big challenge is with those type of products that are from the retail the end user subscriber, they get them and they start playing with the antennas and move them around because they think, oh, I'm going to get better coverage, like we did in the old days with the television and the rabbit ears. They eventually start breaking those things, and then they got to call, hey, Mr. Provider, it's not working, it's broken, I need to replace it. So then you got to go through that process. So on our industry for the provider side, we've gone to exclusively internal antennas to forego that. And we don't run into those issues of broken hardware because really when you look at the gateways and the routers, they're not serviceable like we had maybe in the past where you take it to a service center and they fix it. It's almost better to, just like a television, just exchange it instead of repair it. So we provide the ability to do that, but less issues with broken antennas in an internal design, and with the ability of 1 watt power now, don't have to worry about the form factor, the housing inhibiting the signal. It really has enough power to get its signal across within a deployment area. Great question there.
Thanks. That's a very interesting response. Thank you. Our next question asks, are you able to have OpenSync and TR69 support from the Wi-Fi router?
Yes, that's a great question. Yes, we do have that ability. We're developing that right now. We have the ability to have the best of 2 worlds at one time. So you could have a traditional TR69 and still have the OpenSync and have that ability in a single device. So you have the flexibility to deploy in different operating networks, whether some of it is that traditional remote management or in the new breed of management with the Plume, you should be able to do that, no problem. Good question.
Very good, thank you. Okay, our next question will be our final question. We've had a lot of great questions come through today, and we couldn't get to them all, but we will try our best to get back to everyone who submitted personally after the webinar. So for the final question, if customers have older Wi-Fi devices, what benefit does the Wi-Fi 6 router bring to the network?
Very great question. So just like I explained before, Wi-Fi 6 still offers the ability of working with legacy wireless technologies like the Wi-Fi 5 and the Wi-Fi 4. Believe it or not, those are legacy now. We already progressed. And without having that support, it's not going to really be beneficial to upgrade. Why should I change? If my wireless is working well, what's the big benefits? The other benefits is Wi-Fi 6 allows, besides the speed, it's going to be the amount of capacity. Right now, we see easily 20, 25 devices in the home. And many people are already beyond that. They do 30, 40, 50 devices. You have more than one Ring doorbell. You have a Ring doorbell, and then you have security cameras. You have a thermostat. I have a light bulb. You have plugs that are manageable over Wi-Fi. So all these devices start to add up. And think about it, upstairs, downstairs, and then you invite a bunch of people over. Your kids have their kids come over, their friends, and you just start adding to your network. And all those devices are eventually going to slow it down. So Wi-Fi 6 really helps with that performance. And all your legacy devices are going to have the ability to go up in speed to their full spec. So if it's wireless N300, you're going to get that 270 to 300 megabits. And if it's an AC type of product, 800 megabits on the wireless side, or even more depending on its configuration. So there is pretty huge benefits moving to Wi-Fi 6. Again, if you're teetering on the fence and decide, do I move to it or not, really just take that advantage. Some companies allow for you to test the equipment out before you decide to deploy. That's a great way to kind of kick the tires and do a test drive and see if Wi-Fi 6 really will be beneficial for your network. Excellent question. Thank you so much.
Very good. Thank you. And thank you all for attending this Fierce Telecom webinar and submitting so many great questions. I'd like to thank our speaker, Patrick, for participating, and Zeisel for presenting today's webinar. As a reminder, this webinar has been recorded, and you will be able to access the recording within 24 hours using the same audience link that was sent to you earlier. Thank you again for joining, and we look forward to seeing you at future events.